Hello, you're welcome. Today we have another interesting G advanced math problem, right? And this is an integral problem. The integral from 0 to infinity of 1 divided by 1 plus x raised to the power of 90 dx. So in this video, we're going to evaluate this integral. So let's start by calling this integral I. Okay, so what are we going to do? We're going to start with a nice substitution, okay? So we're going to let x raised to the power of 90 equals t. Now, if you solve for x, we see that x is equal to t raised to the power of 1 all over 90. Now we're going to differentiate both sides. So here we get dx is equal to, remember this property, d dx of x to the power of n is equal to n multiplied by x raised to the power of n minus 1. So use that at the right hand side. We get 1 over 90 multiplied by t raised to the power of 1 over 90 minus 1 and then dt. Now, our original integral I is equal to the integral from 0 to infinity 1 divided by 1 plus x to the power of 90 dx. This is going to be equal to the integral from, remember our limit remains the same because if x is approaching 0, t will be approaching 0 to the power of 90, which is 0, and when x is approaching infinity, t is approaching infinity to the power of 90, which is infinity. Here we have 1 divided by, this is going to be 1 plus t. Then multiply by our dx is equal to 1 divided by 90 multiply by t raised to the power of 1 divided by 90 minus 1, and then we have our dt. So our I is going to be equal to 1 over 90 outside, integral from 0 to infinity. Up here we have t raised to the power of 1 over 90 minus 1 divided by 1 plus t, and then we have our dt. Now we're going to make use of this special function called the beta function, okay? So we have this, that the beta of mn is equal to the integral from 0 to infinity x raised to the power of m minus 1 then divided by 1 plus x raised to the power of m plus n, and then dx. So you can see we can make use of this special function because our integral looks similar to this, okay? So our I is going to be equal to, we need to manipulate the denominator. So we're going to have the integral from 0 to infinity. Remember that at this denominator here, the power here is 1, right? So this shows that we're going to look for a fraction that when you add it to 1 over 90, and that is going to give us 1. And the fraction is 89 over 90, right? So here we have t raised to the power of 1 over 90 minus 1. Then divided by, we have 1 plus t. This is 1 over 90, then plus 89 over 90. And then we have the t. So this is going to be equal to 1 divided by 90 multiplied by the beta of 1 divided by 90, comma 89 over 90. Is that all? No. Now we're going to recall the relationship between the beta function and the gamma function. So we're given that the beta of m, comma n is equal to the gamma of m multiplied by the gamma of n divided by the gamma of their sum, m plus n. Remember that the gamma function is the extension of the factorial. So it implies that the gamma of m is simply m minus 1 factorial. You get the idea? So our I is going to be equal to 1 divided by 90. So this whole thing here is going to be gamma of 1 divided by 90 multiplied by gamma of 89 divided by 90, then divided by the gamma of 1 by 90 plus 89 by 90. So this is going to be equal to 1 over 90 multiplied by the gamma of 1 by 90, gamma of 89 by 90. So down here, this is just simply the gamma of 1. Okay, so the gamma of 1 is just 1 minus 1's factorial, which is 0 factorial, which is giving us 1. Therefore, our I is going to be equal to 1 by 90 multiplied by gamma of 1 over 90, then the gamma of 89 over 90. Now, what are we going to do from here now? We're going to recall the Euler reflection property. So we have that gamma of m multiplied by the gamma of 1 minus m. So this is going to be equal to pi divided by sine of pi m, okay, which is similar to pi CSC of pi m. You get the idea? So here we can actually write this as 1 by 90, the gamma of 1 over 90, the gamma of, this is same as 1 minus 1 over 90, right? So you see, now using the Euler reflection property, we're going to have this is equal to 1 by 90 multiplied by the CSC of pi multiplied by 1 by 90, which is finally giving us pi, oh, sorry, this is actually pi here, right? There is pi here, oh, that's true. So, which is finally giving us pi by 90, CSC, again, pi by 90. This is beautiful. So now we can say that the integral from 0 to infinity, 1 divided by 1 plus x raised to the power of 90 dx, this is equal to pi by 90 CSC of pi by 90, right? And this right over here is just approximately equal to 1.000. Am I getting it? 203. Thank you for watching. Please, if you really enjoyed this video, kindly support the channel by subscribing. Also like, comment, and share.